Hello, I'm James Helfrich. I'd like to introduce you to Security for Software Engineers. I'm going to spend just a minute introducing you to some features within this book, as well as some other teaching materials that are provided. Let's start with the first and most important part itself, the textbook. The textbook has 4 units, Unit 0, 1, 2, and 3. Unit 0 defines security, and more specifically, the flavor of security relevant to software engineers. Unit 1 gives the students an overview of what is an attack and what's the worst thing that could possibly happen. Unit 2 is the meat of the textbook, and this talks about how a software engineer can apply some code hardening techniques to strengthen their code against various vulnerabilities. These include command, script, and memory injection. It also discusses a system for identifying vulnerabilities in a large code base and different strategies for mitigating vulnerabilities. The final unit is about privacy, different tools we can use to provide privacy assurances to our clients. There is also a collection of appendices. These appendices provide the student with an idea of how the various programming constructs are compiled so we can understand how vulnerabilities work in them. To understand how this works, let's take a look at our memory injection chapter. I'm going to bring out the table of contents so we can really dive into this. There are several different types of memory injection vulnerabilities, including array index, pointer subterfuge, ARC, vtable smashing, and so on. But let's take a look at ARC injection as a typical example. We're going to define ARC injection, talk about what needs to happen for the vulnerability to exist, show an example of a vulnerability in actual C++ code, and then talk about how to exploit the vulnerability. There is also a detailed description about what the vulnerability looks like and how the attacker is able to manipulate memory. The same types of things happen for all the other various types of vulnerabilities. At the end of each chapter, there's a collection of examples with a sample problem and a solution provided. There's a whole bunch of these. Some exercises, and each one of these exercises is designed to be achievable by a student after the first read of the chapter. And then finally, some problems, and each problem is far more in-depth. These problems are designed to take anywhere from under an hour to several hours. They'd be good for a weekly lab. The textbook also provides a collection of slide decks, one slide deck for every chapter and for every appendix in the textbook. These decks have placeholders for you to put your own schedule and details about your own course, but also information specific to this particular chapter. Let's go into presentation mode to see how these work. In presentation mode, after the splash screen, we move on to a collection of summary pages, one for content, one for examples, one for exercises, and one for problems. You can easily move between different sections of the slide deck with a single click. In the content, let's take a look at ARC injection, what we looked at before. This has information directly from the textbook presented in a very visual style, facilitating the students asking questions and the teacher answering them. And we can easily move between other different vulnerabilities so we can compare them quickly and easily. At any point in time, I can always go back to the content summary page or another summary page, like examples on stack smashing. And here we have a problem and a walkthrough of the solution, a problem and a walkthrough of the solution. We have some exercises. For an example, name the vulnerability here. Here we have some code. Which one could it be? We'll click on it, and that'll give the student an opportunity to see that this is an example of vtable smashing, as well as provide a description as to why that is the case. And the same thing is true with problems. We would have a problem that's a little more in depth, and then an opportunity for the student to answer them. The goal of this slide deck is to facilitate a variety of different teaching styles. If you prefer to lecture or work through problems or have the student work through problems or to respond to questions, no matter what your teaching style is, this design deck should facilitate that kind of lesson. I hope you'll find this material facilitates integration into a variety of different undergraduate security classes specifically designed for software engineers. Thank you.